Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and in this lecture we will start discussion on another very important systems tract which is called as Transgressive Systems Tract TST. This is abbreviated as TST, Transgressive Systems Tract. So, what is a Transgressive Systems Tract? Already in our lecture on the basic elements of sequence stratigraphy, there we have seen that transgressive systems tract, they will form when the base level starts rising at higher rate with respect to the rate of sedimentation. So, commonly the transgressive systems tract, it is bounded by the maximum regressive surface at the base and by the maximum flooding surface at the top. So, overall the succession, it shows a fining upward trend in general. So, it forms during the stage of base level rise when the rates of rise outpace the sedimentation rates at the shoreline. So, this fining upward succession is actually the result of retrogradational stacking patterns, and overall that leads to this fining upward profile both in the marine part as well as in the non-marine part. Again I am referring back to this curve where we commonly get this transgressive phase during this particular time or maybe during this particular time when the rate of base level change is higher than the rate of sedimentation. So, as a result of this transgression, this TST, what we get is a fining upward succession, overall a fining upward succession. So, the underlying surface, lower bounding surface, it is the maximum regressive surface as it is underlain by an LST, and the upper bounding surface is the maximum flooding surface which is overlain by normally a HST. So, when this fining upward succession is forming, commonly we get this kind of onlapping pattern. So, the system tries to move towards the shoreline moves towards the landward side, and that is why we call this one as a transgression, and all the depositional systems which are forming during this phase of transgression are identified as the transgressive systems tract. So, in this lecture and also in the following lectures, we will discuss about the different aspects of the transgressive systems tract in detail. So, the rates of creation of accommodation during this transgressive systems tract, during this phase of transgression, are going on at the highest rate because the shoreline is moving towards the land because of this rising of the base level. And if you look at that curve, that the gradient of the curve, base level curve, it is maximum. So, the rate of creation of accommodation is very high, which is consumed partially by the sediments supplied into the system, but those sediments are not able to consume the entire accommodation. So, always we are getting some net accommodation available after the sedimentation, and due to that the shoreline will gradually try to move towards the seaward direction. So, when this kind of events are occurring, it will affect all the sub environments across the basin, starting from the fluvial to the marginal marine, coastal, into the shallow marine part and also into the deep marine part. So, we get manifestations of this transgressive event across the basin in all the environments occurring across the basin. So, if I want to understand what are the overall regional architecture that can form ideally in a marine basin starting from fluvial to deep marine part, what are the deposenters, what are the different types of deposits. So, we can start with just an outline diagram to understand what are the major depositional regime and what are the major depositional environment forming during the transgressive systems tract. So, to understand that, we will go through a simple diagram, and there we will start with the unconformity which formed during the late phase of the falling stage systems tract, late phase of the forced regression. So, at the end of the forced regression, we know that this is the unconformity which was continuing up to the self edge. At the self edge, a delta was formed, the self edge delta. So, this is the boundary of that self edge delta, and then in the deep marine part we are getting some high density turbidites and debris flow deposits. Now, during the low stand phase, we have also seen that there will be progradation of the fluvial systems and the delta system, and that will form delta over here, and also some low density turbidites in this portion. So, this part is the LST phase that has formed during the low stand systems tract. So, at the start of the TST, what we are getting? We have this surface available for deposition. This is the final surface which is available for deposition. So, this surface is the maximum regressive surface. Now, on this surface, at the start of the transgressive phase, the base level was here, and then it is rising up. So, the base level is gradually reaching to level 2, for example. So, for this much of rise, what we can expect? First of all, there will be a transgression as the rate of sedimentation is low. So, due to this transgression, the first deposition that we can get is in this area where we get some high density debris flow deposits, again forming over here in this part, and they will be showing this kind of onlapping pattern. Also, we can expect some low density turbidites, again forming over here or over here in the deep basinal part. So, we get two types of deposits. One, some high density sediment gravity flow, normally some debris flow forming over here, but that will show onlapping pattern. So, onlapping debris flow deposits, and in this part again some low density turbidites will be forming. So, commonly the formation of these two units, they take place in two different phases: early phase of transgression and late phase of transgression. The next deposit or the next depositor that we can observe, that we can record in the sedimentary successions, is in this area where we get the delta system which was present over here will try to onlap in this direction, and that will form commonly an estuary in this area, and that estuary will be followed by the onlapping fluvial system. So, this is the fluvial part. So, we get these onlapping fluvial deposits and the estuary deposits forming on the earlier delta system, particularly on the delta plain system. As this transgression will continue, this base level will continue to rise. We can expect that retrogradation of onlap of the coastal sediments or the shore sediments to onlap over here, and the estuary system will come over here, and the fluvial system will further go backward. So, the shoreline will be somewhere here or maybe somewhere here. So, we are getting a first phase of deposit over here in the fluvial area, where we will get fluvial onlap. We will get second phase of deposit in this part, where we will get an onlap of the coastal sediments onto the fluvial, resulting in formation of some estuary. We are getting this third area where we are getting onlap of the marginal marine systems over the earlier deltaic system, producing estuary. That estuary may be replaced by the coastal systems itself, the strand plain deposits or shore deposits during the late phase of the TST. So, we can find out that a major transgression is going on over here, which we can call as the coastal onlap. We can get a fluvial onlap which is going on dominantly in the fluvial part, and a third onlap is going on in this area, which is the deep marine onlap, or we commonly call it as simple marine onlap. Many times this particular unit that is forming during the marine onlap, they are also called as transgressive slope apron. Many times these deposits are also called as healing phase deposits. So, different terminologies are used, but basically we get distribution of the sedimentary packages in the form of retrogradational pattern in these zones across the entire basin. So, the effect of TST, the effect of this transgression is visible in terms of sediment deposition, in terms of formation of sedimentary succession across the entire basin. So, the TST, it tends to be composed of two major wedges, as we have seen in this diagram. So, one wedge towards the fluvial to shallow-marine part, the second wedge in the deep water part, where it is dominantly consisted of the gravity flow deposits and the pelagic sediments. So, these two areas are separated by an area which is commonly an area of non-deposition, that is forming in this self edge area in this part. This area is an area of non-deposition where no sedimentation is going on. This onlapping pattern is not affecting this particular zone. So, we do not get any onlapping retrogradational TST deposit in this particular area. So, this is a no depositional zone in between these two wedges. So, both these wedges, they try to shift towards the basin margin, towards the shoreline or across the shoreline towards the landward direction during the transgression, following the general retrogradational trend which is characteristic of transgression. And during this retrogradational trend, during this backward movement, each and every depositional system try to onlap over the earlier landscape or earlier seascape, and they try to move towards the landward direction. So, when this kind of landward movement is going on, the entire shoreline is trying to move back. The large amount of terrigenous sediments, they get trapped within these aggregating fluvial and coastal systems. So, that results in a cutoff of the sediment supply towards the marine direction, towards the marine environment, towards the offshore direction. So, transgressive shallow marine deposits, they primarily accumulate in those areas which are adjacent to the shoreline, and as the shoreline is gradually going back, those depositors also tries to go back towards the landward direction as the transgression continues. So, when this kind of events are going on near to the shoreline where active sedimentation process is going on and the major sediments are getting trapped in this particular zone, so the relatively deeper part, for example, the offshore area, for example, the self area, for example, the self edge area, they are not getting sufficient supply of coarser clastics, and during those time we expect formation of correlative condensed sections to form. If sufficient mud supply is not there, or if that area is affected by some high energy wave or tidal activities, which is many times the case in case of self environment during transgression, so that can lead to some erosions in the relatively distal part of the self, and that leads to a phase of non-deposition apart from these two wedges, one wedge forming in the deep marine part, second one in the coastal to fluvial part. So, the gradual expansion of the transgressive depozones in the continental self type setting is associated with fluvial onlap, which is the leading edge of the transgressive wedge. As we have seen in case of LST, when the LST delta is forming and it is gradually progressing, the fluvial system starts onlapping towards the landward direction. So, the leading edge of that fluvial onlapping system continues towards the landward direction, continues its journey towards the landward direction through successive onlapping phase during the transgression as well. So, what we get again, a wedge is forming, as we have seen in case of HST, as we have seen in case of LST, a wedge is forming, and we call this one as the transgressive fluvial wedge formed during this TST. This leads to a gradual expansion of the transgressive deposon in the continental part, which is led by the fluvial onlap system. If we look into the deep water part where another wedge is forming, the transgressive deposits are commonly seen to be onlapping the continental slope. So, commonly we call this one as the transgressive slope apron, as I have told you, associated with this marine onlap process. So, these transgressive slope aprons, they try to onlap along the slope which is of relatively higher gradient, and they try to cover up some portions of the slope during this onlapping process. The coastal onlap, they can form within the continental shelf by the shift of the shore face facies on top of the landward expanding wave ravagement surfaces. So, basically when at the end of the LST, when the delta form was prograding, now due to rise in the base level, there will be more wave reworkings, there will be high energy waves acting over there, which can lead to formation of the wave ravagement surfaces along the strand planes, and those wave ravagement surfaces that will try to gradually retrograde. So, on that particular surface we get deposition of the strand plane sediments, deposition of the shore face sediments, which we can consider as the coastal onlap sediments. Now, when initially at the lower part it is the fluvial portion of the TST, it commonly gets affected by the marine onlaps, the seawater onlap, and that leads to interference of marine and fluvial system, interference of tidal, wave and fluvial system. And since this is a transgressive condition, what we expect, we get significant tidal influences within the fluvial system leading to formation of an estuary. We can expect overall finding upward vertical profile, and an estuary comes over the fluvial system. So, what happens in this coastal and fluvial onlap? We can understand that, we can discuss this with respect to again a simple diagram, which is a modified diagram of the earlier one that I have drawn over here. So, we can think of the last surface which was available at the end of LST in the coastal area where self edge delta was forming, and in the continental side that the fluvial onlap was going on. So, in this part we are having a fluvial system which is dominantly a braided river system or maybe a high energy meandering river system, and in this part we are getting a delta plane and delta front or delta lobes forming over here in this area. Now, as the base level is rising up, so that rising of the base level will first lead to some wave reworkings over here, which will lead to formation of some wave ravagement surfaces in this area. Now, on this wave ravagement surface, what we get is the deposition of the coastal sediments, or maybe if we have the delta plane river systems, delta plane channels are available over there, and there the tidal currents will try to interact with the fluvial currents, and so what will happen, we will get widening of the river mouths and formation of estuary in this area. So, on this delta plane and delta front area, we can expect formation of estuary in this direction. And the earlier fluvial system which was starting from here, maybe somewhere here, which was preceding the area of delta plane. So, in that area what we can expect, the fluvial system is now further going back. So, on the fluvial area we are getting fluvial system overlain by fluvial part, but the nature of the fluvial deposits will be different because now the base level is further higher, leading to decrease in energy of the fluvial system. This we will discuss later on in more detail. So, what we are getting in this part at the initial phase of the onlap system during this transgressive phase, we are getting a contact, we are getting a transition. This is the onlapping package that is forming, and within that we are getting a changeover in terms of this kind of within trend phases contact, where this area is the estuary part and this part is the fluvial part. So, on the fluvial part estuary is trying to onlap gradually. When this base level rise will continue further, we will get further transgression, and on this estuary now the coastal sediments which were not getting deposited so far will try to get deposited over here, and the estuary system will go back in this area, and finally here we will get the fluvial system. So, what will be the distribution pattern now if this is the transgressive package or the onlapping package now forming at the late phase of the TST. So, there we will get this kind of the fluvial system forming over here, the estuary system formed over here, which is overlain by the coastal sediments or the strand plain sediments or the shore sediments. So, in this area, when this kind of coastal onlaps are going on, in the basal part we can expect the wave raminement surface to form, whereas when the estuary is trying to onlap, where we get dominant tidal activities, we can expect a tidal raminement surface to be underlying these estuary systems. That we can observe over here, that you can observe in this area as well. Whereas the wave raminement processes will be dominantly concentrated in the outer part, towards the outer side, more towards the shoreline area, where we can expect it is overlain by either the estuary mouth bar area or the coastal sediments which are deposited during the late phase. So, the fluvial onlap is concentrated mostly in the fluvial part, showing overall retrogradational pattern, and that will be sharply transitioning into the estuary system, which earlier during the LST phase was associated with a deltaic condition. So, during this coastal and fluvial onlap, there is one wedge, transgressive wedge forming in the landward direction. There we can get this kind of distribution of different depositional environments, and definitely for each of them we can expect characteristic depositional facies model, characteristic depositional systems. So, this overall grading trend from one depositional system to another during this landward onlap process, landward retrogradational process, that reflects a change, a decrease in the maximum grain size in the upward direction. So, this changeover is dominantly caused by a decline in the competence of the river, which is gradually declining as the time is progressing, as the transgression is continuing, because the base level is rising. Along with that, the river gradient is also decreasing, and the river channels are getting completely flooded, completely covered up, and that is leading to lowering of the overall sand by mud ratio. That means, in the system more mud is supplied. So, channel versus overbank sedimentation, if I compare that, now we will get more overbank sediments, channels will get more frequently flooded, and we will get more overbank sediments accumulating in between the channel fill sediments in response to the accelerating base level rise after this low stand normal degradation. So, as soon as we are changing from low stand normal regressive phase to this transgressive phase, transgressive retrogradational phase, what we are getting over here, during this phase there will be a significant change in terms of the average grain size distribution. In the fluvial component, there will be an average changeover with respect to the ratio of channel fill is to overbank sedimentation. So, this lowering of channel is to overbank ratio in the vertical profile, that also translates into an upward decrease in the degree of amalgamation of the channel fill sandstones during this transgressive phase in the fluvial system. So, what happens now? As we are getting more frequent overbank deposits, they will not allow the channel fills to amalgamate frequently as in case of low stand. So, what we get now? We get isolated channel fills which appear as ribbon like, sand ribbon like features, which are engulfed, which are completely covered up in between thick floodplain fines. So, if I try to look at what happens, so during the LST phase, what we have seen, there are amalgamation of this kind of thick channels, very frequent amalgamation, which is associated with some intermittent overbanks. This is during the early LST. During the late LST, we have seen again some frequent channel amalgamation is going on, but these are associated with relatively thicker overbank deposits, more abundant overbank deposits, but still the channel amalgamation is significant enough. Channel fill amalgamation is quite abundant. Now, when we are coming to this transgressive phase, now the base level is significantly high. So, maybe this was the original channel system where we are getting multiple channel fill deposits. So, the base level is somewhere here now. During the LST phase, the base level was somewhere here. So, due to this extra accommodation, what we will get? We will get channel fills, they are forming, but they are not amalgamating that much because there will be frequent flood, and during this flood there will be floodplain deposits which are occurring in between these channel fills. As we go up, gradually more transgression is going on, more flooding is going on. So, we will get this kind of ribbon-shaped channel fill deposits which is not amalgamating, because by the time it is shifting, we are getting a floodplain deposit is forming, it is engulfing these channel fill deposits, and as a result we will get this kind of separate ribbon shaped sand deposit which are nothing but the channel fill sands. And also along with that, as during this phase, as gradually the marine system is trying to encroach into the land, which will be dominantly influenced by the tidal currents which will try to get access through these channel systems. So, as we go towards the upper part of these transgressive systems, the channel fill sediments will be more tidally affected. They will be more commonly tidally affected channel fill deposits, which we will commonly not observe in case of the LST channel fill deposits. So, in terms of the fluvial channel fill pattern, we can dominantly get two major distinctions. Number one, overall change in the sand mud ratio, it is decreasing, and that is because of the change in the ratio of channel fill to overbank sedimentation. Overbank sediments are increasing, their abundance is increasing during the TST. Channel fill sediments are dominantly not amalgamating, they are remaining separated, they are remaining isolated, forming ribbon shaped channel fill sands. And second point, where these are distinct from the LST channel fills, is within these channel fill sediments, very commonly we expect more tidal dominance, more tidal influence, which we will not get in the LST channel fill sands. The sedimentation of the fluvial deposits during the transgression starts from the downstream reaches of the rivers, where the LST phase has ended, where the fluvial succession is thickest, and gradually it expands towards the upstream direction. So, if this was the LST phase and this is the river system, so this transgression process will start from this point onward and it will try to onlap in this direction. So, in this area we get the thickest deposit, and as we move up the wedge, as we move towards the upstream direction, as we look into the up wedge direction, we will get relatively thinner fluvial deposits. The transgressive fluvial deposits commonly form a significant portion of the incised valley fills, because during the LST already those incised valley fills were partially filled up, but since during transgressive phase the base level is significantly high, they will entirely cover up all these incised valley fills, and not only that, they will also try to cover up the interfluve areas which were formed during the incision process during the force regression, which were not that much covered up during the LST phase. Now those interfluve areas will be covered up, and there we get overbank sediments which will try to aggregate. So, where these incised valleys are present and they are continuing from the previous stages of base level fall, the previous force regressive condition, and are not entirely filled by the low stand deposits, we can expect during this transgressive phase that these incised river channels in their downstream portions will be commonly converted into estuaries at the onset of the transgression. As they are very close to the shoreline, there we can expect very high amount of tidal influences, very frequent flooding by the tidal currents, and we get widening of the river mouth area with intercalation of fluvial and marine systems, producing this kind of estuary system in this kind of river valley system. So, in such cases, the low stand fluvial deposits that overlie the subaerial unconformity that may get scoured or partly reworked by the channel systems which are forming part of the estuary, and also since these estuaries are very frequently affected by the tidal currents. So, we can expect formation of tidal ravagement surface which will separate the low stand fluvial deposits with the transgressive estuary deposits. This already we have discussed during our class on the transgressive ravagement surface, and there we have tried to understand that what are the different locations for the formation of these ravagement surfaces in the estuary system, what are the positions of the wave ravagement surface and tidal ravagement surfaces during the formation of estuary. So, I will ask you to go back that particular lecture, follow that particular lecture to get idea that how this TRS, that tidal ravagement surface or a transgressive ravagement surface, will form at this particular phase. When this transgressive ravagement surface or this tidal ravagement surface, they are not present, they are not forming, maybe little bit inner side of the estuary during the transgression, where dominantly we are getting the central estuary deposits, where the energy condition is significantly low, the effect of tide is significantly low. In such conditions, we can get straightway a contact between the low stand fluvial deposits and the overlying estuarine facies, and that estuarine facies will represent the earliest, that means the stratigraphically the lowest unit formed during the transgression. So, in such cases, in such conditions, we can straightway demarcate a boundary between these low stand fluvial deposits and the overlying estuarine facies that has formed during the transgression, and that boundary can be identified as the maximum regressive surface. They can be mapped in any scale starting from the outcrop to core or well logs, as there we can get an abrupt change from the low stand fluvial deposits, which is characterized by relatively coarser sand, maybe sometimes gravels, which are forming the channel fill deposits, and they are directly overlain by the central estuarine deposits, which are commonly low energy condition, low energy deposits. So, commonly we can get relatively finer grained materials characterizing the estuarine facies. Also, we can expect more varied lithologies, as there we can get channel fills associated with tidal influences. That tidal influences can lead to formation of tidal bundles, reactivation surfaces, bidirectional ripple forms. Several features can form which will be completely absent in these underlying LST channel fill deposits. So, this variation, this distinction in terms of facies types can help us to demarcate the maximum regressive surface in this kind of scenario very easily. Now, apart from all these fluvial deposits, fluvial onlaps which are forming during the retrogradational package during this transgressive part, we can also get coastal onlaps. We can also get this effect of transgression in the coastal areas, and in this coastal area we can get the effect of TST, the package of TST in the form of some backstepping foreshore deposits. We can also get in the form of some diagnostic estuarine facies, particularly for relatively smaller river systems, and when it is a bigger river system, larger river system, we can also expect formation of some delta systems. So, what will be the characters of this kind of coastal onlap pattern? What will be the characteristic of the TST package formed during this coastal onlapping process? That we will discuss in our next lecture. So, this discussion on the transgressive systems track, this will continue in our next lecture. These are some of the additional materials, some of the references that you can follow for getting further idea about this particular topic. So, thank you everyone.